Hello, half-size humans. It is I, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we are going to talk about density and how density affects substances as they naturally sort themselves. In another video, we talk about something called mass. And I'm not going to talk a lot about mass in this video because that is not the purpose of this video. In this video, we're going to talk about density, but we need to just quickly review mass. However, to really learn what it is, you need to go back and watch the mass video. But mass is the amount of matter that an object has, the amount of atoms, essentially, that is in an object. In another video, we also talked about this mysterious thing called volume. And again, not going to talk about volume a lot. Just a reminder, volume is a measurement of the amount of space that an object takes up. An object that takes up more space has more volume, and an object that takes up less space has less volume. In this video, we're going to talk about density. And in order to calculate density, we're going to need to use the mass and the volume of an object. But first of all, what is density? Density is a measurement of how squished uppity, an official science term, squish-uppity an object is. The more squishity uppity it is, the more dense it is. And the less squishity uppity it is, the less dense it is. Okay, well, what do I mean? So if I take a sponge, and you know what a sponge is, right? And I squish it up in my hands and I make it smaller and smaller, I am squishing the molecules and atoms in that sponge closer and closer together, and I am making it more dense. I am not changing the amount of atoms in the sponge. It has the same exact number of atoms. I'm just making them closer together. I am, however, changing the volume, right? Because it's getting smaller. It's taking up less space as I squish it up in my hand. So the volume does change when I squish it up, but the amount of atoms doesn't. Okay? The atoms get closer together. They're more squished up. Well, wait a minute. What if I take a sponge and I fill it with water? Now I leave the volume the same, but there's still more atoms closer together because all the little holes in that sponge, I have filled them with water. So now I have kept the volume the same, but I have changed the amount of atoms. Either thing that I do, in either case, I am making the sponge more dense. Density is a measurement of how squished up, how close together atoms are. And I can change it one of two ways. I can either squish the object closer together, make it less voluminous. I can make it so that it takes up less volume, keeping the amount of atoms the same, and that will make it more dense. Or I can leave the volume the same size, but I can add more atoms into the gaps and increase the mass. So I can either increase the mass or decrease the volume to make the atoms in an object closer together, okay, to reduce the amount of space between atoms in an object. So density is a measurement of how close together the atoms and molecules are. Well, what do you think will be more heavy? This is something that's pretty logical if you think about it. What's going to be more heavy? A more dense object or a less dense object of the same size? So if I have two objects that are identical in size, but one is more dense, which one's going to be more heavy? Definitely the more dense object, because it has more atoms. And remember, the more mass there is, the heavier an object is. Mass increases weight. Okay, so there is a direct connection, as long as we are keeping the same size, between density and weight. There's another important thing to understand, and that is how density impacts the way things sort themselves naturally in the universe. If I take several substances of different densities, such as water and milk and oil and, I don't know, hand soap and whatever, and I put them all into a container together, what's going to happen to them? Are they going to just mix? Sometimes things do mix. But if they have different densities, what's going to happen is they're all going to sort themselves naturally by their density, with the most dense substance sinking to the bottom and the least dense substance floating or rising to the top. A great way to test this is with oil and water. Oil and water don't mix because they have different densities. And so if I try and put them in the same container, the oil will float on top. Okay, hooray. Well, how is that going to impact a wide variety of things? But first of all, let's talk about the layers of the Earth. I will talk in a lot more detail about the layers of the Earth in another video. But just for now, how do you think the layers of the Earth are sorted? If more dense things sink to the bottom and less dense things float to the top, the bottom layers of the Earth, or in the case of Earth, it's round, so the inside layers, they're probably more dense than the top layer, the crust, or actually the top layer would be the atmosphere, right, which is the least dense layer. Okay, and we can apply this to a boat as well. Boats float, they have buoyancy when they are less dense than water, and they sink when they are more dense than water. But you're saying, but wait a minute, Mr. Bertoch. But wait a minute, Mr. Bertoch. I have touched a boat, and it is made out of metal, or at least the one I touched, and metal is more dense than water. So you are a liar, you bad science teacher. But actually, the boat, yes, metal is more dense than water, but it floats because it's not just the density of the metal, it's the density of the air inside the boat as well. So as long as the entire boat, the average density of the entire boat is less dense than water, it's going to float. Okay, so if you take the air inside the boat and the metal on the outside and you average it together, and you get a density that is less than the density of the water, then the boat will float. If it's more dense, then I'm sorry, you are a terrible engineer and your boat is going to sink because you didn't make it properly. What about a log floating on in a lake? Is it more dense or less dense than water? Well, if it's floating, it is more dense. Nope, I lied. It is less dense than the lake, than the water, because it's floating. But a lot of times I can push the log down. It's like barely floating, and I can really easily push it down. Why is that? Because it's filled with water. It's been in there a long time, and it's absorbed a lot of the water. So it's almost the exact same density as the water. And so it's just barely less dense, and so barely floats, but I can easily push it down, and it will slowly float back up. Whereas a beach ball is like, have you ever tried to get a ginormous beach ball underwater, and you're like trying to pull it down, you're using your whole body, and then it like flies out from under you and shoots up in the air like a missile? Okay, and a beach ball is way less dense than water, and so it is not going to go under the water very easily because it doesn't want to. It's going to try and shoot up into the air. Well, what about a helium balloon? What is a helium balloon less dense than? What does it do? A helium balloon does not fly, although it seems like it's flying, but what it's really doing is floating. But not in water, it's floating in the air because it is less dense than air. Not very many things are less dense than the air, but helium is. Helium and hydrogen both are gases that are less dense than the atmosphere, and so they actually float in the air. So what carries, it's like an airship. What carries the balloon up is the fact that the helium and hydrogen are less dense. Okay. Well, how do we calculate? We've talked about now what density is, but how do we calculate density? Because we need to be able to measure it. Measure. We need to be able to measure it. We need to be able to say, this number is what the density is. In science, we are always precise. We always measure things, and we have ways of recording data. So how am I going to get a measurement for the density? Remember that I said density is changed by both mass and by volume. I can either add mass to make something more dense, or I can reduce the volume, squish it up to make it more dense, to make the atoms closer together. So however I measure the density, it has to take into account mass and volume. Okay. Well, the scientists have developed a formula that I can use, that we can all use. It is not, in fact, illegal. It is not trademarked. You can use this formula. Hooray. That we will use to calculate the volume. And that formula is this, and it looks like a heart, or at least I like to draw it like a heart, because that's how I remember it. And that is how you will remember it forever on. You will never forget the formula for volume, because you will just have to imagine a heart with an arrow drawn through it, or an arrow shot through it. It is love, because density is love. Oh, how sweet. The formula is mass. So I'm sorry, let me back up. Volume equals mass divided. Wow. I'm terrible. I'm terrible at this job. You should fire me. Anyway, density equals mass divided by volume. Okay, so the D stands for density, the M stands for mass, and the V stands for volume. And notice that the M and the V form a heart, and the divided line between them makes an arrow. So it is love. Density equals mass divided by volume. So let's do an example real quick. If I have an object that has a mass of 12 grams, I'm going to do an easy one because my brain is weak sauce and I can't handle very hard math. So let's say the mass is 12 grams. And let's say the object, whatever it is, has a volume of 4 cubic centimeters. So I have 12 grams, 4 cubic centimeters. Okay, how am I going to solve this? What is the density? Well, mass divided by volume. So 12 divided by 4 would be what? It would be 3. And so it would be, my density would be 3 grams per cubic centimeter. So the units of measurement for density are grams per cubic centimeter. It's kind of like miles per hour, right? Grams per cubic centimeter. So that's all there is to it. That's how you find out what the density of an object is. You divide mass by volume, and you will be able to record the data accurately for how squishity-uppity an object is, and you will be able to determine, without even doing an experiment, if I put two substances together, which one will float and which one will sink, because you can calculate the density and look at it on paper and say, well, this one's more dense, it's going to sink. And then you can do an experiment, and sure enough, your data will prove to be correct. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up. Subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah, blah, blah. The end. Subscribe. Thank you. Goodbye.